as we get into the unit circle, one thing we want to remember is our quadrantals. We always want to make sure we label out our ordered pairs on the axes. That's the first thing that we did on our unit circle. So as we do that, we know that we were at 1, 0, 0 and 1, -1 and 0, and here we are at 0 and -1. Do we agree on that? Those were our quadrantals. We also labeled those in terms of degrees. 0, 90, 180, 270, or 360. Then we did them in terms of pi. Pi over 2, pi, 3 pi over 2, and then this was at 2 pi. Okay? And we did that already. The next thing that we discussed was just the angles. We went 30, 45, and 60. Now what I want to do here is just work with those three angles and their radian counterpart. So what was the radian measure of 30 degrees? Pi over 6, good. And then it was pi over 4. And then pi over 3. Okay? Do we remember all that? Not bad. Okay. Now, a few things to take advantage of. We know that the radius of the unit circle is 1. We know that our ordered pairs go x and y. We also know that in the second quadrant, what values are positive, which values are negative. Yeah, so in the second quadrant, it's negative and positive. Third quadrant, they're both negative. And then fourth quadrant, we are positive, negative. We remember that, right?
Wait, what are they in the third quadrant?
Negative, negative. Why don't I do the first one? They're both positive. How's that? In quadrantals? Well, because quadrantals lie on the axes. When we're in between the axes, then we don't know yet. But we're going to start right now. We're going to start this right now. So right now, that's kind of all the information we have on there. And obviously, I know we went through the rest of the angles. We'll fill those in as we start out. But I always like to start with just the first quadrant. Because if we understand where our first quadrant comes from, the rest of the unit circle mirrors it. It just changes signs. Okay? So what I'd like you to do is let's see if we remember special right triangles. Exactly. So let's look at our 30, 60, 90. When we wrote these out a couple of days ago, we started writing these things out in terms of x root 3's and 2x's. But you also remember that I also said 1, root 3, and 2. Remember that? So the 30-degree angle, opposite that was the 1, opposite the 90 was 2, opposite the 60 was root 3. Remember that? So, excuse me. That means that the sine of 30, or pi over 6, is what over what? Sine of 30, opposite over hypotenuse, is 1/2. What's the cosine of 30? It's root 3 over 2. What's the sine of 60, which is pi over 3? Sine of 60 is root 3 over 2. Isabella?
I don't.
These are radians. These are degrees. Radians and degrees, they mean the same. They have the same sine, cosine values. Oh. That's a pi over 6.
Oh.
That's all. Okay. Oh, no, you're not. Don't worry. And then the cosine of 60, which is the same thing as pi over 3, 1 over 2. What this is allowing us to be able to do is know how this sets up on the unit circle. One of the other tricks that you're going to find on your unit circle, the ordered pairs themselves, remember it goes x, y, right? When we dealt with sine and cosine, what came first in the alphabet, sine or cosine? What comes first in the alphabet, x or y? The cosine of your angles is your x coordinate. The sine of your angles is the y coordinate. So that means the sine of 30 is 1/2. The cosine of 30 is root 3 over 2. So when I go to my unit circle, I know that the cosine of 30 degrees is root 3 over 2, and the sine is 1/2. That means the ordered pair on the unit circle for 30 degrees, or pi over 2, is root 3 over 2 and 1/2. Remember, cosine, comma, sine. That's the trick. The trick. You do the same thing like we found out for cosine and sine of 60, or pi over 3, if you will. The cosine of pi over 3 was 1/2. The sine of pi over 3 is root 3 over 2. So right now I know that my ordered pairs for 30 degrees and 60 degrees, well, 30 degrees is at root 3 over 2, comma 1/2. 60 degrees is at 1/2, comma root 3 over 2. Okay? We do the same setup for the 45s. In a 45, 45, 90 degree triangle, remember it was 1, 1, and root 2. Remember that? So as we look at that, 1, 1, and root 2, that means that the sine of 45, otherwise known as pi over 4, was 1 over root 2. You agree? But we don't like that. We like it as root 2 over 2. Bless you. And cosine, it's the same thing. Because cosine of 45 is the exact same ratio as sine of 45. 1 over root 2. So you simplify it out to be root 2 over 2. So now when I go back to my unit circle, I know that the ordered pair for pi over 4 is root 2 over 2, comma, root 2 over 2. Now comes the fun part. I think we briefly discussed this on Monday when we were looking at the unit circle. If I were to just draw a horizontal line from pi over 6 to here, what do they have in common on a horizontal line? Horizontal lines, what do they have in common? X values or Y values? The Y value. They share the same Y value. What's the Y value at pi over 6? 1/2. So what do you think the Y value is here? 1/2. Okay. Notice, this angle here was, according to our unit circle, was it 120? What's the reference angle to 120 degrees? 60, isn't it? Oh, sorry. I'm thinking I'm at 60. Yeah, it's 150. The reference angle there is 30 degrees. The radians of 150 degrees was how much? 5 pi over 6. Now, since this is the reference angle of 30 degrees, It's bounced up from 180. It's going to have the exact same ordered pair as 30 degrees. But what changes over here? The x value becomes negative. Because it's negative in the second quadrant. It's magical.
Basically the first quadrant, just the first one.
It's the first quadrant mirrored among all the other quadrants. Because now if I go down, what stays the same, the x or the y value? The x value stays the same because it's vertical. So now this ordered pair, well, that's at 210 degrees, which is 7 pi over 6. That is also at negative root 3 over 2 for the cosine. And what do you think the y value is now? Negative 1/2.
Basically it's the same thing as mirrored, it's just
Watching your sign.
sure.
You just got to know your signs. As long as you know your signs, if you know the first quadrant and where the signs go, it's a piece of cake. Go across. I know I'm saying it's going to be a piece of cake. I know this is the first time you've ever seen it before. But I know that you guys know what quadrant things are positive in. I know you guys know what quadrant things are negative in. It's just a matter of figuring out what the reference angles are. So now I'm in the third quadrant, which means my reference angle is 30 degrees off of 360. So that's 330 and 11 pi over 6. Fourth quadrant has a positive x value, so it's got a positive cosine and a negative sine. What we've created here is just a rectangle. We've created a rectangle using the rules of horizontal lines and vertical lines, looking at what they share in common. Same x values, same y values. So those guys are going to have same cosines, same sines, just depending upon the quadrant. Now, it works for every single ordered pair within the unit circle. As you come across from pi over 4, we know that this becomes 3 pi over 4, otherwise known as 135 degrees. The ordered pair here is going to be what and what? Negative root 2 over 2 and root 2 over 2. I mirror that downward to 5 pi over 4, which is at 225, negative root 2 over 2, comma, negative root 2 over 2. Go across. 5 pi over 4. 5 pi over 4? No, 7 pi over 4, thank you. 7 pi over 4, otherwise known as 315. Now we're at root 2 over 2, comma, negative root 2 over 2. And then lastly, our pi's over 3, our 60-degree reference angles. Our 60-degree reference angle comes across to 120. And let's see, that would be 2 pi over 3. So now we are at negative 1/2, comma, root 3 over 2. Down here we are at negative 1/2, negative root 3 over 2. The degree was 240, and pi was 9 pi over 6, so that'd be 3 pi over 4? 4 pi over, 4 pi over 3. And then lastly, 300 degrees, and add another 6, that would be 6 would be 10 pi over 6, so it's 5 pi over 3. And the ordered pair is 1/2 negative root 3 over 2. Now, is that a lot to know on this? Uh-huh.
Yeah.
But if you know the first quadrant, everything falls into play from the first quadrant. Here's a real short way to remember first quadrant. Look at your ordered pairs. It goes cosine, sine. Do you agree? Cosine, sine. 3, 2, 1. Sine. 1, 2, 3. Look at your numerators. 3, 2, 1. 1, 2, 3. Everything is over 2. You just have to remember the roots, that's all. That's pretty simple. If you look at it, 3, 2, 1, 1, 2, 3. Yeah. Yeah. Radius is 1, but when it works itself out, yes. Okay? Now, if you know this first quadrant, notice how it just shifts with its signs. You just have to remember how they move themselves around the unit circle. What this is going to allow us to be able to do is find the sines, cosines, tangents, cosecants, secants, and cotangents of any one of these angles and their reference angles. For example, I want to find the tangent of negative 210 degrees. And this will be a skill that you guys will be able to do without calculators. You will be able to do this once you're able to remanipulate the unit circle. One of the suggestions that I would give you guys, if you're working on your unit circle and you're starting to learn how to fill them in, create a blank one on your own, or I can make extra copies and give you guys one. Make a first quadrant and mirror it. Just continue to mirror it and work yourself with it. Yeah. Yeah, I usually do. On the tests, on these things, I usually give you a blank one, and I ask you if you want to use it. But remember, if you fill in the entire thing, it takes up a lot of time. So, yeah, you know your first quadrant, that helps, like the crush, if you will. Because I'm looking at you howling. The joke, playing words. Oh, it is unlocked. Look at me. So if you know that, you'll be all right. So let's look at negative 210. First thing you want to figure out is where in the world is negative 210 degrees? We need to find its reference angle. Since it's negative, what direction are we going? Clockwise or counterclockwise? We're going to go clockwise. So as we come around, there's 180. If I came all the way up here, it'd be at 270, so it's somewhere in here. Okay? To figure out what the reference angle is, well, how far up did I come off of 180? 30 degrees. So my reference angle is going to be 30 degrees. So think about, on the unit circle, what had a reference angle off here at 30 degrees? It was 150. Okay? Do you agree? So what is the ordered pair at 150 degrees? Negative root 3 over 2 and 1/2. You remember that? Now, that's x and that's y. Tangent is y over x. So it becomes 1/2 divided by negative root 3 over 2. Now, I wrote it horizontally right away because you're going to have to multiply by a reciprocal. We okay on that? You can write it as a complex fraction, whatever. So it's 1/2 times negative 2 over root 3. You get negative 1 over root 3, which is negative root 3 over 3. There's your tangent. And it all stems from being able to solve for the reference angle. Once you get the reference angle, then it's a matter of knowing the ordered pairs. Yes, this will take a little bit of time for you guys to understand what your ordered pairs are, because you just now, for the first time, saw where sines and cosines occur according to the unit circle. So as you're doing these, remember, reference your unit circle. Yes, ma'am?
Where did that 150 come
It's the reference angle.
from?
What we
The
did,
angle was 30.
what I'm saying here, the 30 degree is the reference angle, but what theta has a reference angle of 30 degrees in the second quadrant? 150. Remember, your theta, 180 minus theta, is your reference angle. So theta was the 150. That's what I'm solving for. I'm figuring out what theta is going to be. What angle has that reference angle of 30 degrees? I think I might have said it, but I didn't show algebraically how I did it. Okay? Yeah.
So long as that's going to be like 30, 60, or 45.
Yeah. Yeah. If it's not, then you're going to have to use your calculator to solve it. Okay? Let's try another one. Cosecant of 11 pi over 4. I want to figure out what the cosecant of 11 pi over 4 is. Well, let's figure out where 11 pi over 4 is first. What's 11 divided by 4? Or how about this? How many times 4 go into 11? 2 and 3/4. So that's 2 and 3/4 pi. 1 little, 2 little. Okay. 3/4 pi is in what quadrant? First or second? Because that's half the pi, so it's over here. Okay? Now, if you think about it, we were around 2 times, right? Or to 2 pi. Then we came up 3/4 pi. Isn't there already a theta at 3/4 pi? Yeah. It's 125, I believe, right? 135, excuse me. So what is the ordered pair at 3 pi over 4? Negative root 2 over 2 and root 2 over 2. Do you agree? Remember, this goes x, y, or cosine, sine. Cosecant is the what of sine? Inverse, thank you. I know what you mean, but it's the inverse. It's the inverse of sine. So if the sine of 3 pi over 4 is root 2 over 2, the cosecant is going to be 2 over root 2, 2 root 2 over 2, otherwise known as root 2. You guys are just all going. It's crazy. Once you get into it, seriously though, once you see what we're doing by getting this reference angle, it's just the ordered pairs. That's why I had you guys going through sine, cosines, and tangents. You x's over r's, y's over r's, things like that. That's why I'm telling you, your ordered pairs, cosine, sine. If you know that, everything flips around. Okay? Whatever. Minute?
Yeah,
And we get out of 18.
18? Sweet. We got time for one more. Nope. All right, we'll use some homework. It's 789, I know that. 45 through 60. Okay? Ha!